Good morning and welcome to our session, bringing together IaC and CM with Terraform provider for Ansible, which is part of 90 Days of DevOps 2024 initiative. First, let's start with a little thing about me. I'm Razvan Ionescu. I'm principal technical trainer with Beam Software. I've started my career more than 20 years ago with deploying infrastructure in data centers. And I was doing racks, patch panels, UPSs, up to configuring networks, switches, firewalls, servers, and even storage area networks. I've noticed firsthand the data center transformation that happened over the last decades and is still happening today. And I've been directly involved in automating such transformations. First of all, I'm not going to go through the infrastructure as code theory, at least not all of it. I'm just going to touch a few points. And one of the things that I would like to discuss is we have changed our way of creating and managing infrastructure from a quasi-manual process, which was filled basically with UI clicks, to a more programmatic way of doing it. This new process is called infrastructure as code. Infrastructure as code is basically a methodology for managing and provisioning infrastructure through machine-readable files. Simply put, instead of doing manual tasks, we treat infrastructure as software. As you can see on the slide, we have here two representations that achieve the same result. On one hand, we're looking at the UI, it's Google Cloud Console, where we can go and create our own web servers, well, compute instances. And on the other hand, we have some code that when it is being run by a specific tool, it will create the same compute instance in Google Cloud. Why would we prefer one to another? Well, when we use infrastructure as code, we can achieve consistency. So our infrastructure will always look the same. We can easily achieve scalability. We can run that code multiple times. We can put it in a loop and create multiple VMs very fast or downsize it. We achieve collaboration, and the collaboration refers to teams, members of the same team being able to work on the same infrastructure. Otherwise, they would have to basically read a lot of the documentation, ask the other team members, and interact and spend more time trying to figure out what they need to do and how to improve things. And we can achieve efficiency. It's way faster to deploy infrastructure by running code than by executing manual commands in an UI, however simple that UI is. Lastly, one of the biggest properties and my preferred property for IaC is idempotency. This is the property that comes from computing, from programming, and it means that every time we run the same code, we get the same result, no matter how many times we run that code. Having this property embedded in our IaC, we basically make a huge step from the days where deploying the same infrastructure twice would be pretty much a gamble. How do we achieve this? Well, number two concepts on infrastructure as code is how do we tell the tools, how do we tell the machine to achieve a specific state of the system. Our brains work in a way where we need to describe basically step by step what we want to achieve. So if we put ourselves a goal, then we start making small steps, creating small steps in order to get to that goal. We can do the same way with the infrastructure. In this sense, we become imperative. We describe each step that we want our machines to do in order to deploy a specific architecture. Let's look at a very simple example. We want to install a web server on a specific port and make sure that it started automatically. If we are doing that in an imperative way, we would basically start and write small pieces of code that tells the tools that we're using to check whether the web server is already installed or not, to install the web server packages using a specific package manager, to do the configuration of that web server. So basically add a line in the configuration file to listen to a specific port. Then we would like that web server to be enabled to start automatically upon reboots. And finally, we would run the command to start it. It can be done using different tools, it can be done using scripts, but it's still an imperative way of doing the things. If we don't want to do this micromanagement, we can actually give a lot more freedom to the tools that are deploying the infrastructure, and we just move to a declarative way of constructing it. So we tell the end state that we are looking to achieve in a format that the machine understands, and we let the machine choose exactly the order of the steps. We let the machine do those nitty-gritty details behind it. In our example, we just tell it, okay, I need you to ensure that our web server is running on this VM on this specific port, and it is started automatically. We really don't care how it's doing it behind in each order it's doing it. So those would be the two main ideas that I wanted to emphasize regarding infrastructure as code theory. Now, let's look at an example where we start by provisioning, because today's presentation is about doing provisioning and doing configuration management and having those two together in the same process. We have this code that declares how things should look like in the end. And with the code, we can create what we're going to do. We're going to create networks. We're going to create a server on the network. We're going to open firewall ports. And in the end, we will do some configuration. The creation of the network elements, the creation of the firewalls, it's considered to be infrastructure provisioning. We're going to use Google Cloud as an example, and we know we have some APIs. Those APIs can be reachable, that can be reached via the UI, but we don't want to do that. We want to use some automation behind it, and we have different tools that we can choose from. It can be Terraform, it can be Pulumi, it can be Hit if you're running on OpenStack, or if you're in AWS, to be AWS CloudFormation. All of these are doing the same thing, provisioning the infrastructure. We chose Terraform because this tool has been created with the single purpose in mind, provision infrastructure. At a high level, the architecture of Terraform is made of a Terraform core, which is a statically compiled binary that calls some plugins. Those plugins that are supported right now are called actually providers, and they are executable binaries that expose an implementation for a specific service. In our case, we're talking about the Google Cloud APIs. The plugins are using client libraries to make API calls against that service. Using the provider, Terraform will basically be able to execute and create the infrastructure that has been given to it through the configuration file. So as a user, we're going to write the configuration file, our infrastructure as code. We both understand it, both meaning us and Terraform. Give that to Terraform. Terraform will use the providers to create the infrastructure. And the last thing, and the other thing that will do, it will keep the state of that infrastructure in a specific state file. So Terraform knows how the world looks before it executes something and how the world looks after it executes something. And in the state file, it will put all the details about the resources that it has creating using our configuration file. Having the plugins and this plugin architecture allows very easily for Terraform to be extended to other services, be it public clouds or premises, Kubernetes, or even network components, right? So we can go and write our code for multiple types of infrastructure. We're not gonna look into it in today's session. There is a registry, a Terraform registry, where you can find all the supported plugins, and you can also write your own. We have now our Google Cloud infrastructure deployed, right? The VPC, the firewall rules that allows us access to the VM that is running in that VPC. However, we need to deploy an app on top of our VM. Usually VMs, usually infrastructure, serve some purpose in life, and that would be an app, a service. As for the tools to use, we can go back a little bit back in time, and you can do it manually. So open a console SSH to that web VM, install using the package manager, or we use some scripts in startup scripts in the UI. However, that doesn't really fit our purpose, automation, and it can become pretty messy. So we want to apply the same principles like consistency and idempotency and also efficiency when we do the configuration management. Luckily, we have a panel of tools available. We're talking, just to name a few, Ansible, Chef, Puppet. Those are all configuration management tools. Yes, they do some infrastructure provisioning, but we're not going to go into that discussion. We're going to use the tool for its intended purpose. And what we chose today is Ansible. Now, you can choose whatever tool makes sense to your environment, to your team, to your skills. Remember, you choose the right tools to help you best do the job, because in the end, it is you that will have to work with that tool and basically maintain it and live with it. For us, it's Ansible. At a very high level, Ansible also needs a configuration file where it is told, machine readable, right? It is told what to do, what are the steps to create during that run. The configuration files for Ansible are called playbooks. So we're going to write this playbook and give it to Ansible. Now, Ansible will take it and needs to know where to apply it, against which host to run it. So for that reason, it will look at an inventory file, unless we want to tell it directly in the command line. That inventory file will contain a list of hosts to which Ansible will connect, and will run the playbook. So basically do the configuration. Once that it's clear, Ansible can do the connectivity to our web VM. Remember, we have the firewall rules that allows us the connectivity, and install our application on top of it. Putting it all together, so bringing in the infrastructure provisioning and the configuration management, gets us to the situation where we need to reconcile two states of the environment. On one hand, Terraform is dynamically creating and destroying resources in the infrastructure. It keeps that information in the state file. On the other hand, Ansible needs to have some information in the inventory file to which host it can connect, and it needs to run the playbook against to. So in order to make the reconciliation between the state file from Terraform and Ansible's inventory file, we will be using Terraform provider for Ansible, which will allow to, and you'll see how in the demo, will allow to have dynamic information sent between Terraform and Ansible. The other provider that we're using for Terraform is, of course, the Google provider, because we're using Google Cloud. Ansible will use SSH to connect to the provisioned VMs. So it is now time to look at the code. So it's demo time. We have here a pre-recorded demo, but it's going to be fine. First of all, we look at the Terraform file. The Terraform file has a main file. Well, it's a pretty simple configuration here. We have a main file where we declare our infrastructure as code, and we have an outputs file outputs.tf. The outputs is just to send some information out to the console. And also we have the variables file where we initialize, declare and initialize the variables. You can see here at the beginning, the two providers are defined with their versions, and then we start basically configuring infrastructure and resources. So we have the VPC, Google VPC created. Then we have a subnet in that VPC. We need some IP addressing, and also we have firewall rules. And in this situation, we're going to create three firewall rules. We're going to open port 2280 and 443. The source range is there where it is not the best practice written as a comment. It's just for this demo. Don't do it like this unless you have a good case. So we've created the free network resources with Terraform. We're defining now how to create the fourth network resource, which is our web VM. As you can see, it's pretty simple. We give it a name, we choose the size, each medium. We also tell it what image to use, what boot disk to use, in this case, Ubuntu, and dynamically connect it to the newly created network resources, the VPC and the subnetwork. In the end, the other thing that we just need to do for this VM is to open the possibility to SSH to it. And for that, in the metadata field, we add an SSH key that will be injected in the VM for obvious reasons. I'm not going to show you this key here. And that would be our fourth resource that Terraform will create in Google Cloud. And with that, we ended our infrastructure provisioning. It is time to start creating, doing the configuration of the infrastructure. So what we want to achieve is to deploy a very, very simple web app on top of a newly created VM. What we have, the first thing that we added here, it's a resource that it's a time slip. So it's basically we're waiting a random amount of seconds for the VM to boot up or the services to boot up. I chose it 20 seconds. And the next resource that we're using, it's an Ansible host type of resource. And we're going to use this resource. And basically what we're going to use, it is the external IP of the newly created web VM to define dynamically our Ansible hosts for the inventory file. The web group, it's just a way of mapping playbooks against hosts. So we'll be using those, it's some kind of metadata basically that we're using to let Ansible know that we can run a specific playbook against the specific hosts. And we also tell Ansible how to connect to that host. So we give it a user to use, SSH key, the one that was injected via metadata. And also here we put the Python because I have multiple Python versions installed. Lastly, we run two Ansible commands. The first one is just for the beauty of it. It's run Ansible inventory -- graph. It's basically looking at the inventory file and it's presenting a graph with what hosts exist in that inventory. And also it can present information about different variables if you want. So if you want to see what the user you're using to connect, you can display it like that. It is very good in debugging informations, but it's not mandatory. The other thing, so this can be skipped, but we'll keep it here and look at it. And the other thing that we are going to actually do is to run the playbook. So the resource Ansible playbook called Ansible playbook will execute the playbook webvm.yaml against the hosts in the inventory that are, well, in the web group defined. And that is the whole file with Terraform. In this file, we already put infrastructure provisioning and some commands for infrastructure configuration. However, the configuration files are put in separate. So we're using Ansible. So we have here two files. Again, it's a very, very simple example. In the inventory file, like I said, normally you would have hosts defined there because we're looking for dynamically creating those hosts. Here, we don't write anything except a link to the Terraform provider. Yeah. And this is the binding element between the Terraform and Ansible, this line here. Then we tell Ansible what to actually do. As you can see, we start with defining on the playbook which groups of hosts to use, and we put here web, and then the tasks to execute. So ensure that Nginx is at the latest version, which will basically look if the package is installed, and if it's not, it will install it. Then start it. Then it will do here a little bit of cleanup. I just removed the default file for Nginx, and then we're using GitHub module from Ansible to get the app from GitHub, which is not a real app. It's two files, an index file and then an image. Now it is time to actually look once again at my InTF, and it's time to start running this code. So first of all, we validate. We run a Terraform validate to make sure the syntax is correct. It's fine. Before running the plan, before starting actually deploying infrastructure, let's just quickly check the Terraform state file, the one that is dynamically updated by Terraform with infrastructure, with the resources created. And as you can see, there is nothing in it because we didn't create any resources now. After we do this, we're gonna do a plan. So we're gonna let Terraform run through the main TF file and analyze what it needs to create, but it will not execute anything when we run the plan. As you can see, it has 8 resources to add. And once we did that, we're gonna go and apply that plan. So we're gonna tell Terraform it's time to configure and run everything. We need to confirm it, and this will start deploying the resources. The first thing starts in the order in the plan. It starts creating the VPC, subnet. You can see here the firewall rules that are being created. Then it goes and it starts creating the instance, the compute instance of our VM. And well, this is the recording is a bit fast forwarded. Yeah, it skips some time waits. After it finishes the deploying the VM, it will go to the configuration part. It did the time slip, and then it's running it created also the Ansible host. And once it creates the Ansible host, you can see that we already captured the external IP address of that host, so we can connect to it. And then we're running the graph command. And you see here that graph command presents us the inventory in a graphical mode. And also it's the same IP that was captured earlier when we created the host. It's also present now in the inventory for Ansible. If you have multiple hosts, you'll get all that information in there. And finally, we run the playbook. And when we start running the playbook, we're gonna basically let Ansible take over and execute the tasks that are defined in that playbook. So first it gathers facts, so it connects over SSH to the VM, then gathers task, and then it starts installing Nginx. It starts it, removes the default, downloads the web page from GitHub, and Terraform is done. Also Ansible. At the end, we've displayed an URL. We used output, Terraform output, to create that URL with the external IP address of the VM. And it's time to check that it works. If it works, yeah, we should see this. So that's the famous application that we deployed from GitHub. Basically, it's a simple web page with the title of this session. If we go back now to Terraform state, we'll notice that it has been populated with the new infrastructure. You can actually see on the right side, it's a pretty long file. One thing that you need to take care, very sensitive information in Terraform state. So there's a long discussion about how to protect it, where to encrypt it or not, and things like that. I'm not gonna go through it because of that reason. I'm just gonna show you the first link. So that concludes our session for today. And I just showed you how to bind together dynamically provisioning infrastructure with Terraform and configuration management with Ansible. Thank you for your time and well, hope you enjoyed it.